majority of my audience is from reality capturing world. So we are doing laser scanning, photogrammetry, we are creating 3D Gaussian splatting and everything else. So my question is, based on your knowledge, do you think that reality capturing companies are leaving money on the table if they deliver just point clouds or just 3D meshes?
Yeah, I mean, so reality capture or digital twins is way beyond than a photorealistic 3D representation of the space. You can unlock so much value with the existing data that you already have, and some of that today we will be showing down the line in this podcast. Is, yeah, I mean, if you're just, let's say, creating a scan and just leaving it out there without adding more value, you are leaving money on the table. And throughout this podcast later today, we'll show you what additional things, use cases you can unlock with the existing data that you have.
I already have had several discussions with different people regarding the digital twins, what is and what is not the digital twin. And the majority of them said that simple point cloud or 3D mesh, it's simply not a digital twin. Even if when I suggested that it could be a digital twin of LOD0, it was not accepted. So the difference between just simple point cloud and digital twin should be more obvious. How would you say, like, what should reality capturing company do to just move from doing just scans to actually delivering a digital twin?
Yeah, I mean, there's lot many definitions. For starters, is obviously digital representation of your physical space. But as you told, right, I mean, it's beyond that. Like, as I mentioned, like what else you can unlock. So it could be modeling. I mean, from the existing digital twin, it could be a live digital twin, which is not just a static 3D representation. It could be a evolving live version of the reality, which gets updated as the reality is changing, right? So it's I would say it's more, if you just are stuck at the 3D point cloud, which is a static, I think you're one step behind. A digital twin, according to me, is a live representation of any physical space, right? And it should unlock more value than just being a 3D representation.
So is it right to say that with your solution you can just upsell the already captured data? Like, is it true that you really don't need anything more than just what you have already captured to be able to offer something more to your client?
Yeah, that is true. So with multiset, when we started multiset, right? I mean, even before starting, when we were thinking of this problem of localization, spatial tracking, we had multiple reality like when we were going and implementing this in venues, they had this, hey, we already have a 3D scan that we did from Matterport like a couple of years ago. Can you use just the existing one and not to do a rescan, because we don't want to do so many rescans just to enable this particular use case. And that's where the idea for multiset was, that we wanted to enable, there is billions of square feet of scans already done from varieties of sensor, whether it's LiDAR, I mean, within LiDAR, there are so many different providers, whether it's 360s, whether now it's Gaussian splats. So with multiset, the idea is, if you already have a scan, irrespective of the provider, you can use that scan and unlock spatial tracking, indoor navigation, real time localization, robotics, and so much more, just with your existing scan.
I know that there is a lot of not fights, but like different diminishing ideas and comments because the whole like the broad variety of techniques how we can capture the real space, it's going from like 360 cameras up to like high-end terrestrial laser scans, okay, the mapping solutions and slimes and everything else. So there is like a huge difference in terms of quality, in terms of accuracy, in terms of clarity of images and everything else. So how would you like communicate with different clients, because saying to the guy doing just the 360 video on site with his helmet camera, compared to guys doing high-end terrestrial scanning for weeks of the same plant. Uh, uh, do you really want to tell them both that, guys, it doesn't matter to us, like both sets could be used for our solution?
Yeah, so I mean, as you mentioned, right? Like we have so variety of data from a 360 camera to a SLAM-based terrestrial scan, or like a traditional terrestrial scan, like Matterports and Leicas of the world, right? So obviously, the quality of the images, the point cloud, the accuracy matters. From a multi-set side of perspective, we do give recommendation. Hey, if you are doing a small space, you can in fact use a 360 video. You can use a like a low end 3D scan. But if you are doing like a really large space, we'll recommend you to go with the higher end of the scanners like NavVis, Leicas, even Matterport for that matter, right? So we have the recommendation in our documentation. But what from a multi-set side of things, what we try to do is, if you are following that recommendation, the quality of the localization that we produce is very consistent, right? So it's not like, hey, if I have a 360, I'm going to get really bad quality localization tracking. You will still see the median, accuracy that we propose, irrespective of the input type. And that's the job that we do. Like our pipeline does it normalizes all the scans, all the point clouds, all the panoramic image, and bring that into a standard pipeline.
Okay, so I think we did a bit of a teasing of how reality capturing company can like upsell their already delivered product. So can you just explain to us, what do you actually do? Like, what does Multiset AI do with the captured data?
Sure. I'll start with a very like layman definition, and then go deeper on what it does. So, what Multiset AI is a visual positioning system platform. What does that mean? In short, it's called VPS. So, we have been using GPS for almost 50 years. It was built by US government almost in 1975, so it's like 50 years. And that was the core positioning engine that we use almost on our daily basis, right? Whether you are riding an Uber, you are ordering your food, everyone uses GPS to know where they are in this world and communicate their location precisely with respect to each other, right? So that's the GPS. It works great outdoors and indoors. It mostly doesn't work because we know how GPS works is in triangulation, and so indoor the accuracy is quite bad. So whenever we are taking an Uber, we go out and then write the book a Uber, so for Uber driver to know where we are, right? So it has its limitation. What Multiset does is it builds visual positioning system, which is an ultimate accurate version of a GPS. You can think in that way, where instead of connecting with satellite, it uses your phones or devices camera to see what's around you and match it with a database and give you an absolute 6 degree of freedom of coordinates. So which means it's more accurate than GPS, and it can give you not just position but also rotation as well. So it can unlock values that GPS couldn't earlier. Let's say for augmented reality, for robotics, for AI glasses, you just don't need position, you need accurate position as well as rotation as well, of where you are with respect to world. Where are you looking at? Are you looking left or right? Right. So from a high level perspective, Multiset builds scan agnostic visual positioning systems, which helps you to track a device which is camera enabled in a given 3D world or a given physical world.
I would like to dig deeper into this term, visual positioning system. You already mentioned GPS, and for anybody working with scanning and georeferencing, and has touched surveying industry in any way, they already know the GPS, they know the GNSS. So we can just firmly say that it's working very accurately outside. The problem is when we go inside, right? So what's the main problem? Why doesn't it work like the classic GPS or GNSS inside?
Yeah, so why it doesn't work is it's because how GPS, I mean, you have to go deep into like how GPS works. Is just it connects your phone, which has a receiver with a lot of satellites which are flying out in outer space, and it does a basic triangulation. So it basically receives those rays and then try to triangulate. It needs at least, let's say, three satellites. It's try to triangulate, say, where is this device, if you know three known satellites in the world space, right? So that's how it works. But what happens outdoor, you have clear line of sight, which means the signal that your phone or device is receiving is direct with the satellites. There's no obstacle in between. But as you come indoors or in like a dense urban corridor, the signals bounces between the walls, between like trees, between anything which is, let's say, obstructing the signal from your device to satellites, right? And that's impacts the accuracy significantly. So now instead of having a direct connection, you are receiving the signals which are bouncing off multiple surfaces. And that's why, like, let's say a GPS would give you an accuracy of 3 to 5 meters outdoors, but as you move indoors, the accuracy goes like 30, 40 meters, or even uh, bad. um, and not just vertical or horizontal accuracy. I'm also thinking about vertical accuracy. So determining which floor of the building you are, right? Let's say if you're on seventh floor, eighth floor, right? The vertical accuracies gets even worse. So determining where you are in a building just using GPS, that's why it becomes harder and harder.
What are current solution like? Why your solution is different? Just explain to me why do you think that your approach is better than compared solutions? Because I already have seen the navigation panels in like shopping malls, for example, or at the
Yeah.
airports, right? They are able to somehow locate me and to know where I am. So how is it different, or what different solutions they are using
Yeah,
nowadays?
so when we think about positioning or indoor positioning, or even outdoor, we have GPS at the highest level. Then we have Bluetooth beacons. I'll come to that in detail how they work. And then we have Wi-Fi. Then we have ultra wide bands, which are again all hardware related solution. Which means if you put all that into a single term, whether it's Bluetooth beacons, Wi-Fi, RSSI, or ultra widebands, the main disadvantage of those is two things. First, they are infra heavy, which means, let's say you want to enable accurate positioning in your environment or a factory or a shopping mall, you need to install those beacons everywhere at a regular distance. It's like having mini satellites in the physical space, right? Uh,
So beacons meaning simply some kind of a
yeah.
sensors, right? Within
Yeah,
the space.
some
Yeah.
sort of sensor which can stick on walls, it can stick on roof, right? So but you need to install them, like multiple of them. You need to install them, you need to maintain them, you need to charge them, they need to like form a mesh. So whether it's Bluetooth, whether it's UWB, there is a physical, infra required in the environment to be present for them to work, right? So and on top of them, although you have invested that much, let's say, upfront in on infra, the accuracy level that they offer ranges between, let's say, 1 meter to as high as 5 meters, right?
Why such low accuracy, I would
Yeah,
say?
it's just a cost function of like how this technologies works again. So the underneath formula is still same. So how GPS used to work, it used to connect your device with this satellites in the space. How, let's say, a Bluetooth works, it tries to triangulate your device position with respect to multiple sensors. So if you are in a room, and it will try to catch three sensors, like, hey, one sensor is in this room, one is in another hallway, another is in that hallway. It will try to do the same stuff, but instead of using the signals from GPS, it's trying to get the signals from the Bluetooth sensors that are installed there. The the problems are still same. So when you're catching the signal, although the signals are stronger because the devices are very close proximity to you, the way the triangulation works uh, is it has the same principle, that it bounces through the walls. It has the physical boundaries, the physical infra impacts the triangulation ultimately, right? And on top of that, another thing, it can't derive your rotation, which means although I know I am in this room, I, for let's say for navigation and tracking, I also want to know where I am looking into the room. So not just like a blue dot, but when you open Google Maps, you also want to know, yeah, like you see the compass, right? Like, hey, I am facing this way, this way. So that helps like a navigation, like an app to know, hey, are you going this side of the lane or you're going in the opposite side of the lane. So it also lacks the rotation component.
Okay, let's see if I understand right. So with these beacons or sensors, it's happening the very same thing as with the satellites, that I need at least three sensors to catch me, to like locate me, for the whole system to be able to give me a position, a location. Each sensor or each beacon can just say like, you are within 3.5 meters, for example,
Yeah.
from me. Yeah, but it doesn't really know which direction or where exactly. It only knows that it's 3.5 meters, for example, based on the strength of the
Yeah,
signal. And I need another two for the system to being able to just actually locate me. Am I right here? Do I understand it
that's
right?
right. Like, so you need at least three signals to, coincide and triangulate your position. Hey, this is how the line of sight matches. According to this signal, this sensor, you are in this line of sight at this distance. According to this sensor, you are in this line of sight, and where they coincide in the physical space, that's how they work. And that is where that's where your position is with respect to those three sensors.
Okay, and the typical precision or accuracy of these beacons is within like decimeters, right? In tens of centimeters, let's say, or in a
it,
meters.
it, it really depends. So if you are like uh, 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 in a I mean, if you want a higher accuracy, you can install as many sensors as you want, and it can then, let's say, give you accuracy less than 1 meter, but then it increases your cost of deployment significantly, because the number of sensors you install in the physical space, the higher the accuracy you get, but it still be limited to, let's say, in centimeters, or let's say tens of centimeters. But the cost function is going higher and higher, right? So the amount of investment is not giving you that fruitful investment in terms of accuracy.
With your visual positioning
Hmm.
system, uh, we are not speaking about any beacons. You are working without any additional hardware. Am I
Yeah, so
correct?
that's the just coming back to your initial question, right? How, let's say, a multi-set a visual positioning system is, different or better than, let's say, a traditional positioning based system which relies on Bluetooth or Wi-Fi or UWBs. Is the first thing is no infra required, which means, hey, if you already have a 3D scan, you don't need to install anything else in your infra at all, right? Which means, you don't need to go on the site, you don't have to procure so many sensors, you don't have to drill so many holes in the physical infra, and then have the wiring, have the all the mechanism built in, right? So the initial investment becomes significantly low, because it's completely hardware free. It simply relies on a database, which is a scan, a digital twin, uh, of that particular environment, and tries to match your camera's frame with respect to an existing database, right?
As you mentioned, like if you want better accuracy or if you want to cover bigger space, you need more beacons. So it actually means that with the size or the accuracy, it comes with more money need to be spent on installation and on the hardware, right? So are there any limits for your solution for the visual positioning system? Do you have any limits in terms of size or the accuracy?
Yeah, so
Like I want to compare. Like I want to do a small, I don't know, warehouse of 5,000 square meters compared to big industrial plant of hundreds of thousands of square meters.
yeah, so coming I mean, considering the first question regarding the accuracy, multiset VPS operates at accuracy of 5 to 10 centimeter, and with the 2 degree of rotational accuracy, so which is significantly much accurate than any hardware based solution yet, because the way it works is it's actually using computer vision AI and using your camera device to recognize very precisely where you are. So that's where we can deliver, let's say, 10 times more accurate positioning in indoors than, let's say, traditional Bluetooth or UWBs, right?
Have you done any benchmarks? Have you done any tests to
Yeah,
confirm that?
so we have, I mean, Multiset has been benchmarked by an independent body called AREA, which is Augmented Reality Enterprise Alliance. They did benchmark with Multiset and all other VPS providers. Multiset has been the most robust out there. And in our independent benchmarks, the way like we put our accuracy, there are some blogs which I will link. We claim, let's say, a median accuracy of 5 centimeter, but 5 to 10 centimeter, and median rotation accuracy of 2 to 3 degrees, right? So that is like uh, uh, way more accurate than, let's say, Bluetooth or UW build systems will provide you.
You said several times something about the rotation. So, compared to traditional systems of positionings indoors, you say that with the visual positioning system, you can actually also know the position and rotation of the tracked camera, not only the simple position, but actually it's called a
Degree of freedom. The
6D of
Yeah,
freedom, right?
yeah.
Can you explain this
Yeah,
term?
so 6 degree of freedom, I mean, 6 DOF, or in a long, I mean, full form, it's called 6 degree of freedom, which means the position that system like a VPS, like multi-site returns, is not just like your XY coordinates, it's in position, it's XYZ. So, in like, since we live in a 3D space, we tell you where are you in respect to 3D space. So, just not in the planar space, it's also gives you position in XYZ. So you can also ultimately determine whether user is on first floor, ground floor. If the user is on like, you can also just estimate the floors, right? And coming to the rotation, right? And rotation is pretty key for the use cases which a VPS can unlock, which, let's say, a Bluetooth based system cannot unlock, is because, let's say, a lot of augmented reality application, a robotics application, they also need to know where you are, like, not just where you are in this space, but where you are looking into the space, which means, hey, what is your heading? Are you looking down? Are you looking left? Are you looking up? So 6 degree of freedom means the rotation in all three axes as well, which means position in all three axes, as well as rotation in all three axes, which means we can precisely, and I'll show you some videos down the line where I can precisely tell where is user standing as well as where is user looking. So whether it's up, down, left, right. If you see this particular screen, on the right we have a Meta Ray-Ban which has nothing but a camera, and on the left you are seeing the Meta Ray-Ban being tracked in a Gaussian splat. So you can see, like, we are on the right side, we are precisely able to track where the device is in respect to the physical space, and also when the device rotates, we can also estimate its rotation in the physical space. So it's not just position, but you can also track the, track its movement in the physical space. Again, the same representation here, where, let's say, you as a person who is wearing the glasses, we can track not just position but also the rotation, which is very key for application in robotics, augmented reality, when you are overlaying any sort of digital content, or your robot is navigating from room A to room B.
So can you tell me like how it actually works, the visual positioning system? If I'm understanding it right, you are simply relying on what camera can see. Okay, so you have somehow captured the data, so it doesn't really matter if it's 360 camera or terrestrial laser scan or SLAM or whatever, but you have some imagery which is with some geometry and in some system, either local or a georeference, doesn't really matter. And then you have a camera enabled device, so it could be, as you showed, the glasses, or it can be a phone camera, or it can
Yeah.
be whatever
Yeah.
camera, right? So what does it actually do, the software? Is it like checking for the similar pixels, or how does visual positioning running in the background? How does it work?
Yeah, so I will start with a simple definition and then go deeper on like how actually it works. So from a simple terms, we have a database of how an environment looks. You can capture that database from, as you mentioned, from a 360, from a LiDAR scanner, from a Gaussian splat, right? So you have a, let's say a static digital representation of an environment, and now on the other side you have a device which is camera enabled. So as you mentioned, it can be any device. Right now on the screen you are seeing a Meta Ray-Ban, but it could be an iPhone, it could be an Android, it could be a robot which has a camera. So how it works, it compares the what your camera device is seeing and matches it against the database of already a 3D scan that you have created, and gives you a position with respect to that 3D scan. Hey, this is what you have in the database and this is what you are seeing right now. So we know that you are in this position, in this rotation with respect to that 3D space. Sorry. And if the 3D space is already georeferenced, we can also give you georeference coordinates. So you can, in a global space, we can determine where you are, using a 3D scan. Now, going into deeper how it works, it looks for a lot of unique features, because if you think of a large 3D scan, it could be built up of millions of point cloud or sometimes billions of point cloud, right? And you don't want to process all of them. So when you are building this database, you're looking for unique images that are very distinctive. You're looking for unique features. You're looking for unique geometry, and you are actually creating a machine readable map. And that's very key, that hey, you have this 3D scan. Once you upload it to Multiset, we create a machine readable format for it, which means it's a proprietary way of storing that map in such a way when a device is actually doing a query, it can do that query very instantly. So irrespective of the scans.
So does it mean, so sorry, does it mean that you are on the background, that you are simplifying the data sets and you are picking only like the important points and important geometry from the scene, or
That's
what do you do
Yeah,
on the
that's right.
background?
So let's, from a user perspective, when you, let's say, upload really large 3D scans, and I think since your audience has worked with reality capture a lot, sometimes this 3D scan can go as big as hundreds of GBs, right? So, and you don't, and a lot of that data is repetitive, maybe not usable for a VPS. So we do, convert the raw data into our proprietary machine readable way, where we only keep the unique geometry, unique features, unique images that are actually worth storing for a VPS system. And the way we store it, uh, it's become a hierarchical information, which means, hey, you have a 5,000 square feet scan, or even if you have 500,000 square feet scan, the amount of time it takes for a device to recognize or localize its position is almost same. So which means, although the size increases, the time it takes for you to use the system doesn't increases at all, right? So irrespective of the environment size, the cost of deploying, the cost of running is almost same. So that's our proprietary way of how we, ingest this large scans and convert into a format that can be so scalable.
I'm using, for example, the terrestrial laser scanner from Leica, the RTC360, and it has the VIS system. Basically, what it does is that you the device can actually understand in the space where it is at the moment. So it helps with the scan
Yeah,
registrations automatically in their app. Uh, are you familiar with this
yeah,
feature?
yeah. So
So is it something similar?
uh, uh, from a concept level it is, but from when you are designing, like, I mean, for, let's say, if you're when you're registering two point clouds, you just look at the geometries. You are working with the same modalities, right? You have one point cloud, you have another point cloud. They are coming from literally the same scanner, same type, and the concept is same. You are trying to, register two different point clouds, but uh, when we're talking about VPS, the modalities changes significantly, which means the devices that you are using for positioning only have a camera. It doesn't have a LiDAR. It doesn't have fancy sensors. But when you captured the space, you used a high end, like a NavVis or a Faro, any sort of scanner, right? So since the modality changes, and another challenge with VPS system or designing a VPS system is uh, a VPS has to work with dynamic environment. So today, let's say you did a scan of a shopping mall in early morning, no one was there, and now you want to do the localization when there's a lot of crowd, the lighting has significantly changed, the environment is different what you captured, right? So VPS system is built to handle those sort of challenges. With multiset we could handle different lighting. So let's say you scanned an area outdoor in daylight, and you want the device to work in almost low light or nighttime, multiset VPS can still work. You scanned a space in a lot with no crowd, and now you want a system to work with crowd, let's say for event spaces where, hey, you scanned this scan when there was no one in the event, and now you want it to work when there's a lot of people attending the event, the VPS system would still work. So the key is how robust the localization can be.
Okay, two questions come to my mind. The first is connected to several comments we have in the chat. I'm not going one by one because there are multiple that touch more or less the same point about how similar does the scene need to be compared to the scan. Okay, the premises, industrial plants or shopping malls, they are changing instantly, like every other week,
Hmm.
for example. How what's the percentage or how much of a scene can change for multiset AI to still be working precisely?
Yeah, and this is a great question, and and this was one of the problem that we wanted to solve when we initially designed multiset. uh, let's say the existing point cloud based registration or VPS system were quite impacted by changes in the environment. So how multiset AI is different is it's using deep learning models underneath, uh, to uh, compare what was there and what the image which is coming now. So it's quite robust to handling changes. We have multiple benchmarks and case studies done where we have scanned like a event space when no one was there, and now we trusted the system when there's a lot of crowd. So I mean, there's no exact percentage, but as long as it's visually there's something for a system to recognize from a database, it will work. So even if it's like 10%, 20% of the area is same, it can still work, right? The accuracy might degrade, but the system would still be reliable enough for you to do your navigation. uh, uh, but let's say if your area is completely changed, like you did an event and now the area is completely changed, what you get with multiset is map versioning. What does that mean? Hey, how can I quickly update this map again without reconfiguring all my navigation and things like that? With multiset, we have one touch update where, hey, you did a scan 3 years ago, and after 3 years, you see so many environment changes have come when you are seeing degradation in accuracy. You can simply go ahead and scan and do a one click update, and multiset will make sure that it registers the old and new scans, even though if it's coming after years of changes, after I mean even from a different provider, right? So we with multiset we have that particular feature as well. We call it map versioning, where you can have different versions of the maps which were taken years apart.
Are you also showing like I don't know, like a level of confidence or level of accuracy? Because uh, I understand the map versioning, but still, it's happening that the site was scanned in one condition and it's being navigated or tracked in other conditions. So, do you like online show the level of confidence for the positioning, or you just
We do.
show the position and don't care
We
about
do.
the
So every time you, let's say, use the multiset APIs or SDK, and you are doing like an actual query to the multiset service, hey, here is my image where I am in this 3D space. So when we send the response, we also send a confidence interval, which like ranges between 0 to 1. 0 means least confidence, and 1 means like highest confidence. And a lot of our developers have then added checks where, hey, if my confidence is more than zero point 0.3, I'm good enough. This much accuracy is good enough for my use case. But let's say, hey, you want like millimeter or centimeter level accuracy, will set my confidence at zero point 0.5 or zero point 0.6, right? So you can think of a confidence between 0 to 1, and which as a developer or as a system designer, you can tune it like, hey, I want more accuracy, I want less accuracy, I want my poses to be absolute accurate. um, Multiset handles all of it. And on top of that, we with Multiset, this is first in industry uh, query systems where we do a lot of sensor fusion, which means uh, instead of a lot of VPS just works on a single image, a single viewport. Multiset offers a way where you can send multiple images together and their SLAM data. And what it does is, instead of looking for one corner and one piece, which could be repetitive and could bring in the additional inaccuracy, Multiset does sensor fusion, which means if we send us 4 images, we do the sensor fusion, and in that condition we can give you even more accurate and robust result, right? So it's really on developers on how they want the accuracy and for their use cases.
AJ Krieg is saying that this is a very similar solution compared to VR system and motion tracking options. Is he right, or is there a fundamental
So there
difference?
is a lot of I think in VR and AR there is something called anchors, which are local anchors or world anchors. The way a VPS like Multiset is different than an anchor is quite limited in scale, which means you can do an anchor in a room and it will only work in that particular room, right? Like it's typ- typically at a room scale. Like you can quickly create a map and like create an anchor and do the tracking with respect to it. Where a VPS system shines is at the scale, right? Like, hey, you are deploying a positioning system at the scale of 100,000 square feet or 500,000 square feet, sometimes millions of square feet, right? So and you don't want to go and scan from your mobile phone, which is very less powerful. It has limited RAM, basic cameras, right? A VPS system is designed for scale, so which means you can implement a tracking system at 100,000 square feet of scale, right? So it's not just at the room scale or even at apartment scale. It's at factory level scale or industry level scale, right?
Are you intentionally like leaving out features that are being changed like during the capture? Like, for example, if I capture from two different places while doing laser
Yeah,
scanning, for example, I can see the difference in the point cloud. Like on one point there is particular unit or object, on the other scan it is not. So are you intentionally leaving this geometry and imagery out, or?
that's right. So what we do internally is attention based feature tracking, which means instead of like, hey, if you have like 10 features and giving everything as the same weight, we try to distinguish, hey, this is the most uh, unique feature in the scene, which is more trackable and has less chance of being changed, right? So if you are like seeing in my background, if there is a curtain and the curtain would have a lot of features, but those are not the unique features. But let's say if there is something which is static in the environment, it could be that hole on the knob, it could be uh, how the floor looks. We look at millions of features, or sorry, not million, but thousands of features in an image, right? So, and we try to prioritize features that uh, have less chance of being changed. So let's say if there is a human in the query, let's say, which is very a regular chance when you are using the system, you might have a human in your query image, right? Like you captured some image where is like some couple of people standing in front of you, right? So we will just ignore those people and then try to look what is beyond those people when you send us the query image, right? And this is not just on the human, this is done on thousands of categories which we think have more weight or less weight. And that's how we could work in scenarios where there is very simple looking white corridors, but this VPS could still determine, are you on the left corridor or the right corridor, just looking and prioritizing the features that are unique.
Here's the question. From large database of feature map, how do you fetch the current region of features so that feature matching can happen between the live features and the stored features? I think this is connected to the scale. The question is probably focusing on if you have too big database of features that you detected during the processing time, how fast or how accurately or how do you handle the big scale and the indexing and just like matching the feature from the live camera to the database?
Yeah, I mean, without sharing a lot of secret sauce, uh, I would try to answer in that way where um, when we are building the maps, uh, we are dividing the maps in such a way where it's not like a one big map file. It's stored in our proprietary format, which can be indexed and then can be retrieved uh, from a one particular section, which means so when you, even irrespective of, as I mentioned earlier, irrespective of map size, you are not searching across the full map. So the level of searches that happens, you first even sometimes you can give a GPS hint. So we take that GPS hint and just search in that particular area. We have our internal way of reducing the search scope. So there are multiple chains of search happens, which reduces the search scope at each level. So ultimately, uh, uh, from top to bottom at every level, we'll filter a, we don't want to look into this area, don't want to look into this area, and we just want to focus on this area. And this all can be also customized using our APIs. So let's say a lot of times when you are using a visual positioning system, you kind of know that, hey, my user would be on this floor or on this part of the floor. Can I give that as a hint to the VPS system so it doesn't like go beyond that scope? So with multiset, we have that capability where you can give like a hint position, hint height, or any sort of geo hint, which means it could be a GPS code, GPS values, and it will just restrict the localization search in that particular area.
Mhm. Okay, but let's go away from the navigation, because you mentioned before that it's only one part of the solution, and maybe even more interesting could be the actual tracking of devices within because yeah, for example, navigation in a shopping mall, you really don't need a
Yeah.
centimeter accuracy. So even with the traditional beacons, it can be solved like accurately enough. But it might be different for tracking. So what can you actually track?
I mean, I'll start with this, like the navigation which we were talking. Let's say this was particularly done using a Matterport scan, where on the left you are seeing the navigation arrows flying, and on the uh, so yeah, this is typically a workflow looks like. You first localize, which means your system actually detected where you are, and then you sort of get this list, hey, where you want to navigate, and then in the augmented reality it overlays all the information that you need there, right? uh, there's some more example of the same thing happening. So you can not just overlay paths here, but you can overlay additional let's say in augmented reality you can overlay 3D objects, you can overlay textual messages. So on the right you see there is a full, I mean, some of our developers, they are creating a full like a virtual walkthrough of how the space will look like once it's built in augmented reality. So what they're doing is, once you have tracked an environment, you can place very precisely augmented contents in that environment. So even let's say you want to visualize how the building will look like once it is built, um, or you want to visualize something which is not there, but you want a system to track your location and overlay those precise digital elements. That's what tracking can unlock, and that's what we are showing in this particular video. On the left you see there is a video being played on exactly a location, a YouTube video being played, and on the right, on in like a in a backyard, you have this whole setup which was not there, but since you have tracked your device, you can overlay this digital information on top of it, right? And coming back to the whole source of it, it's actually a 3D scan. So if you already have, let's say, a 3D scan, you can do this out of the box without going onto the site. So if you have a client who wants to overlay something, and if you already have a 3D scan, they can do this out of the box.
We do have a question regarding the different scanners or different techniques to capture. So uh, if I scan the environment using a device from other than Leica, Matterport, NavVis, or XGRIDS, will it still work with my platform? With your
Yeah,
platform?
I'll share my screen. This is what will look like when you log in. Multiset has an amazing free tier, which means today you can go to developer.multiset.ai and create an account and start experimenting, which we discussed earlier today. But to get started, the first thing typically our developers do once they create an account is go into the map section and they click on create map. What does create?
Sorry. I want to stop you right here. For reality capturing professionals, what do you mean by map? What does it mean? The
Yeah, so
map.
that's a good question. So a map, uh, uh, from a multiset as definition, is a single unit of a reality scan. So a map could be like a 3D scan of a apartment. It could be a factory floor. So a single point cloud file, it's an E57 file, a Matterport file, or a PLY file, is a map for a multiset. So why we call it map to a scan is basically we are converting that scan to a map which devices can use to share and navigate upon. That's why we have this terminology from where you have one single unit of scan, which is, let's say, it could be a point cloud file. You come into multiset, you create a map, which is basically you're converting your scan to a map which downstream devices can use to localize, track upon.
So can we just say that the map in your terms is simply any 3D assets that you
That's right.
upload?
Yeah, it could be any 3D asset which you, let's say, an export from a professional grade scanner. I'll just come to like the type of 3D assets that we accept, but yeah, there's one-on-one relationship between a 3D assets and a map.
Yeah, before you tell me which 3D assets you accept, I would just add the statement here. It's probably more file format dependent and not the hardware. So can we just confirm that it really does not matter which technology or brand or which way to capture the space you use? It really depends on what file format are you trying to upload.
Yeah, that's true. So uh, we accept file formats like E57 file, which is like a vendor agnostic format which has both point clouds and panoramas. So file format matters, but ultimately we also like have some guidelines which you, let's say, click on our documentation. It tells you what exactly we need in those files based on the scanner type. So if you come here in our developer docs, you will be able to see like this all are the scanners type that we support, and for each of that scanner, how do you go and export that particular file that we need, right? So we have step by step documentation based on the scanners that you have. But even if you have, let's say, scan like hardware which is not listed here, and you think it still exports all the data that we need, you can just choose one of this uh, provider and go ahead with it. So as long as the file format matches and the data in that file matches, we can accept that.
Okay, so without like being specific on the scanner like producer or whatever, uh, uh, just fundamentally, do you need alongside of the point cloud data? Let's consider the point cloud to be
Yeah,
colored, right, with RGB colors. But do you still need imagery? Do you still need panoramas, or is the colored point cloud enough?
we do need panoramas along with registered along with the point clouds. Point cloud can be colored, it can be non-colored as well. It's not mandatory. What we need is panoramas plus point cloud from LiDAR scanners, which a lot of LiDAR scanners that are listed here exports out of the box, so you don't need to go ahead and use a third party tool to do it. all the scanners that are listed here export that out of the box. You just have to enable settings, which is like how you export that. It is all listed in our documentation. But from a high level perspective, yeah, we need panoramic images as well as point cloud.
What if I'm not using colors during the
That is okay.
scans?
We don't need.
I can export you panorama, but it still will be in a 50 shades of gray. So it's still going to be only black and white. So is it okay?
That should work, yes. So although it's not the recommended flow, but if you, let's say, have already a panoramas which are grayscale, it will still work.
From a typical SLAM solutions, do you accept unordered point clouds? Like, is it okay to have unified point cloud?
Unordered. So we do require. I mean, we have like XGRID as a I mean, SLAM scanner out there. I have the XGRID device here, but the point cloud has to be ordered, which means, let's say, you need to like process it to bring all the panos, to bring all this point cloud in a single unified local coordinate system, and then do the export. So a lot of workflow involves you to first, hey, you have captured the raw data, now you go on that particular hardware's local software and then export like a E57, which will do all the filtering, ordering of the panoramas, and then export like a file that multiset can accept.
Scanning positions from terrestrial laser scanners are not required for your system to work, right?
Scanning.
That's like the basic difference between unordered or unified data and ordered data is whether you know or you don't know the scanning position of the scanner. That's why I'm asking about this. Like, you don't need exact scanning positions from terrestrial laser scanner, for example. You can work with unified point cloud. Yeah.
We do need, let's say, if your terrestrial laser scanners like a Matterport has 100 panoramas, so when you export like an E57 or Matterpark, they do give like the position and rotation for each of that panorama. So we need like a unified point cloud, the panoramas, and what is the position and rotation, basically pose.
Okay. So you need the position of panorama, but you don't need
No, we
ordered
don't
point
need.
cloud. So it can be unified, simplified point cloud, but with the positions of
Order doesn't
panoramas.
matter,
Okay.
like, so irrespective of order, order doesn't matter as long as it has the panoramas, point cloud in a single coordinate system, as well as poses in the relative space, relative coordinate space, which means it starts from 000 and moves into the direction of your point cloud.
Can we go back to the business side? Because, like, all the way up to this live webinar, we were teasing about how you can upsell the your already scanned data, and we just went through features. How does it work? How the positioning system works. I think it's very, very important because a lot of guys from our audience are from scanning business, and they might not be familiar with how the positioning system works. So I still think that it was beneficial to hear this and to discuss this. But I would like to go back to the business case. What would you suggest? Like, what do you think is a low hanging fruit from people doing? Like, most of the guys would be doing like scan-to-BIM projects, for example. Okay, so they scan the site for the documentation. They have a point cloud, they have panoramas, they produce the documentation. That is the final delivery so far. So why did we claim before that you can actually upsell your project again? And what would be the low hanging fruit? Like, what would you suggest to do first if they want to use your solution with their existing clients?
Yeah, so this is a great question. So I'll start with how you can use multiset as like a reality professional who even doesn't know coding and is used to existing tools and you want to use it out of the box. So um, we have a partner ecosystem, which means like today we multiset, you don't have to come to multiset a lot of times. We have partners which I'll go over in a bit. You can start with our partners, and the lowest hanging fruit, I could say, it's the navigation, which means, hey, you did this scan for a shopping mall which was used for them to understand how the shopping mall looks, or like just a simple reality capture. And now you can basically go and upsell them, hey, I can do a navigation link for you, which means I will come, I already have the 3D scan, I will give you some QR codes which you can put in your entrance, and all your visitors which are coming to that shopping mall can use that QR code and would have a directory to navigate against it, right? Which means and then you can charge upon this based on how big is the shopping mall, how big is the, I mean, how much audience they are expecting. And this could be beyond shopping malls. I mean, there's a lot more value which we unlock today is for enterprises do, I mean, as you know, a lot of digital twin modeling. They do keep maintain their digital representation, so which means the scanning is a continuous purpose. And what you can unlock for an enterprise is beyond, like you can also prove ROI, which means, hey, you have a factory floor which has thousands of assets, and you already did a 3D scan. Can I build a navigation system which helps your workers to identify where the assets are placed? So when they are locating an asset, it's so easier for them to go and locate an asset with this visual guidance in augmented reality that it saves their time. Like 20% of the time on an average goes in locating an asset on a factory floor, right? So with a multi-set VPS and let's say navigation enabled for an enterprise, they can cut down that locating time and then give their workers a system which help them to locate different assets on the factory floor, right? Coming to my first question, we Multiset is a developer platform, it's an infra platform, but we do have partners which provides a no code solutions. A couple of partners that I can mention is 3ds. A lot of your audience might be already familiar with 3ds. Multiset is, let's say, it's already integrated with 3ds connected worker platform, which means if you are already on 3ds and if you are enabling augmented reality today for using navigation, for using for displaying a lot of digital twin information in AR, you're already using Multiset. But let's say you just want to focus on appless navigation. We have partners like Zappa Spaces, which have a dedicated platform built where you can import the Multiset uh, VPS map directly and build a navigation no code in an appless way, which means
Yeah, maybe since you mentioned the 3ds, just for the audience, the 3ds is the third party platform for Matterport scans, right? Where you can like enhance already captured data with
yeah,
Matterport. So you mean that
that's
3ds, yeah?
right.
Okay, okay. Do you have some use case that you could show
Yeah,
us
yeah,
from
yeah.
3ds?
So if you uh, can play the first video again that we played for the last time.
Yeah.
Yeah, just right here. So one thing you could do is, let's say, set up AR instructions. So think of this as a trackable, like an, it could be a map, it could be an object, but what 3D like a platform allows, they have this, a really amazing 3D editor, a no code, low code 3D editor, where you could like see a scan and overlay uh, some sort of digital information on top of it. So it could be an object, it could be a full scan. And then what you could do is when you enable that in augmented reality, people who are like working on that particular equipment or working on that particular uh, piece of hardware, right, they will see the same sort of digital like representation or annotations that you created, right? So this is something what 3ds unlocks, where uh, you already have a scan, you can go into 3ds platform, you can enable augmented reality in your scans and have these annotations in their platform created. And then you could use an app, or it could be an app list like a link to see this annotation in augmented reality on that particular equipment, right? So you could like this is a very basic example, but you can imagine you could overlay manuals, you can overlay step by step instruction on how to fix things, how to train someone, and this is all possible with 3ds.
Okay, but this use case is on a small object, relatively small object. So I guess that this is achievable also for with the traditional like AR approach, or where you can trigger just based on the visual anchors. So I would be more interested in showcase of some like bigger space or site.
Yeah. So this is another thing which you could do. uh, uh, so this is again like a environment of a factory floor. You see a lot of repetitive motors here. One thing you could do is, and this is also where you are, we have integrated an AI agent into it, which means let's say uh, you are selling a solution where a worker who is on the factory floor is asking question, hey, it's just let me play for that particular moment. Yeah, here, hey, what motor requires maintenance, right? So what will it the system will do first, it will determine from a system of records from all your data, I mean all your backend system, is which motor was scheduled for maintenance. It will first identify that, and then it will then navigate you to that particular equipment, right? So you can think of a worker who is on the field. He doesn't have to navigate across dashboards, and to locate that particular asset. What it will help is, uh, uh, you could talk in the natural language and it will overlay all the information that you need for that particular instance, right? So it will overlay, hey, this is the motor, this is its ID, this is how you can reach out to that particular motor and do your work, right? So the time it takes for you to locate that asset on the in the field, it's significantly reduced, because all the information that you're seeing today is through your tablet or your phone, and in future it could be the augmented reality glasses or AI glasses that you are wearing, and it will overlay all the information there.
Okay, but your system is not actually doing some recognition of the equipment on site. So like all the devices that I want to query, they need to be indexed and like tagged before, right?
Yeah, so
Manually.
there are ways to tag them automatically, but yes, and this brings me to the first question, like what is the definition of a digital twin, right? So a digital twin is like a lot of enterprises maintain, like from a 3D scan you have a layer where you have all the assets tagged. Hey, this in this 3D scan, this is where my motor is placed. So since multiset works on all the derived data, which means if you already have, let's say, a digital twin where it's not just about the raw sensor data, like raw scan data, if you have annotation already done somewhere, you can directly import that into multiset, because multiset works off of the same coordinate system or the same reference system which you earlier used to annotate all your systems upon. So to enable, let's say, a multiset like system, you don't have to re-annotate. If you already have annotation done in a 3D scan, you can bring in the annotation as well as you can bring in the raw 3D scan as well.
Can you tell me like what is the typical project for the implementation of multi-cell? Like what type of a building or what type of facility is like the maybe easiest or typical for multi-set?
So I'll show you kind of facilities that we map. So I think I'll start with the sort of modalities. So uh, first of all, we also have a in-house mapping app. It's like similar to Polycam. So let's say today you want to test out the multiset and you don't have a digital twin, like, or a 3D scan, you can like download our app which works on all the iPhones or iPads which has a LiDAR enabled device.
Okay, that's quite important information.
Yes. So you can get started today. Just type in multiset in our app store, or and you will be able to see the multiset app, and you will be able to experience all of this or try out all of this without even being having a existing 3D scan. So that's the first way people start.
Sorry, but you need a iPhone with the
That's right.
LiDAR, yeah. You need the Pro version, so it will not work with Androids or
Yeah,
other phones.
for 3D scanning, you would need like a iPhone with LiDAR or an iPad with LiDAR to get started.
Now, all the haters that don't consider the sensor in iPhone or iPad, the lidar, please leave your comments. We know that it's a big marketing miscommunication from the iPhone, but they are calling it lidar, so I'm calling it lidar. Sorry for that.
Yeah, it's a very low resolution LiDAR, I know, but it does a lot of job. Like here, instantly you can see it's doing live meshing, which is like really important sometime when you are building like a 3D representation. Although it's not the most accurate and the higher resolution, but it's good enough for, let's say, a prototype level, and that's what we need. I mean, that's why we have the app. We want, developers to get started quite easily instead of like having a big bulky scanner to try out the multiset. They can download our app with all the iPhone Pros and iPad Pros and get started. um,
I usually don't recommend people to scan more than like few square hundred meters. So, for example, for like small boiler rooms or something like that, the iPhone scan could be perfectly fine, and you can you can
yeah.
leverage 100% the
Yeah,
multiset on
yeah.
it,
So
right?
we have this in our documentation mapping equipment. So where we recommend like equipment type based on the space size. So let's say if you're scanning space up to five, like up to from starting from a room scale to even sometimes apartment scale. And believe me or not, we have some students who have used an iPhone to capture the whole campus uh, uh, in a smallest ways, like five like 1,000 square feet in a way, and then they have merged all the scans in multiset. You can,
I will have to cut. I will have to cut this out from this podcast. I would never recommend to do something like that. But kudos for them if it worked.
yeah. So yeah, we have the equipment list like based on the size of the scan. You can use the multiset app to start with, and then we recommend like as you're going higher, start with Matterport Pro 3, which is really good. If you want to go even for higher, uh, NavVis, Leica, and recently, like just in last couple of years, I think XGRID is something which is quite exciting. It can export both Gaussian splats and a point cloud, and we support both as an input, a Gaussian splat as well as a point cloud. So uh, XGRID fits some.
So sorry, because we didn't touch this before. When you say that you accept the Gaussian splats, uh, how does the localization work within the Gaussian splats? Do you actually use Gaussian splats to
Yeah,
localize, or do you use like the supporting point cloud which is coming along from the
we use
XGRIDS?
Gaussian splat to localize, and this is what we have built first in the world. Like there are existing VPS system maybe who could work with a point cloud and images, but we are the first tracking system which can take Gaussian splat file natively and convert that to a visual positioning system, right? For this, we use something called novel view synthesis, which means from a Gaussian splats we generate a unique data set that we need for a visual positioning system to work. Uh,
Okay, but like the usual problem with Gaussian splats is their inaccuracy. Okay, because they like lack the
yeah.
geometry. They are just a bunch of splats. So how do you get that accuracy in VPS in position
To
system?
start with, we support certain kind of Gaussian splat, which means those have to be. If you come onto the platform, you can, when you select Gaussian splat, we ask you like some of, like today we support XGRID Gaussian splats because those Gaussian splats are generated using an LiDAR sensor underneath, which means we can guarantee that the point clouds are accurate and at the metric scale, which is quite important when you are like working with uh, Gaussian splats. I'll just share my screen. So this is like when you come onto the multiset platform, this is what it looks like. As I explained, we have an app which you can get started today. This is the app which works on iPhone Pro and iPad Pros to get started. That's the best way to start prototyping. And then if you already have a existing scan, this is the interface that you typically start with. You either choose a LiDAR as an input, which has point clouds panoramas, as we discussed earlier. You choose a Gaussian splat as an input, or in the end, otherwise you choose a 360 video, which is the most newest form of input that we have supported. For Gaussian splat, for each of these providers, when it's choose, we give you like a list of options to choose. So for Matterport, you can choose the Matterport and select which particular file format you are inputting. For Leica, we support E57 files. For XGRIDS, we support E57 as well. For XGRID, one particular way is a Gaussian splats, which means something like a portal cam, which is amazing device to capture, metric scaled accurate Gaussian splats. So if you have a like a portal cam and you want to give it a shot, you can export portal cam output as .ply and like just come here and upload it to the multiset. We ask you like just
Okay, but with the portal cam or generally from XGRIDS, you still will get at least the sparse point cloud. So I think my question before was fundamentally wrong, because what I actually meant is that you are doing positioning on or tracking on a Gaussian splats, because you can easily like identify the position of the camera, but like actual localization you have to translate it from the point cloud, right?
Yeah. So a Gaussian splat gives you. So what we do from a Gaussian splat, if you think of Gaussian splat, those are like point clouds where with I mean actual splats, which are like these surfaces which contains like how a surface will render, right? So we just take that as an input and can convert that particular Gaussian splat into the database that we eventually need for a VPS to work. How we do it is we use something called novel view synthesis and understanding the actual geometry of the splat, and then determining where the cameras was placed initially. We can also you can also give additional data like poses, which XGRID exports. Uh, and we accept all that in a zip, and then you can simply convert that into a VPS out of the box, right? So quite a bit goes on based on the input type, like how we convert that to a VPS, but ultimately the goal is accept as broader input type as we can and convert that to a tracking system.
Okay, I will ask it differently. If I create a Gaussian splats scene from iPhone camera or from DSLR, or if I use 360 camera and create the Gaussian splats scene, will it work?
It will not. It will not, unfortunately, because unless it is a metric scaled. So one thing with Gaussian splat is how you created those Gaussian splat is something called metric scale, which means like is your Gaussian splat one on one with the real world? Which means if you measure like a window in your Gaussian splat, does it actually have the real dimensions of the real world? So that's like a first filter for us. Uh,
Okay, so that's the
yeah
scaling
yeah the
problem, yeah.
scaling problem. So if you
Okay.
let's say if you have let's say done manual scaling on a Gaussian splat, then it can work, right? But if your let's say Gaussian splat is not uniformly scaled and it's not real world scale, it will not work. For a VPS system to work, we need the Gaussian splat to be scaled, metric scaled.
Do you have any more nice use cases that we could show to our
Yeah, I
audience?
wanted to go into robotics, which is because that's something we want to go and go beyond, let's say, an app or an AI glasses, which is quite exciting, uh, and go into robotics, which is like what additional things you can unlock. This is what this video is showing: a robot being localized from a point cloud that it captured on its own. So if you see this robot, it has this LiDAR scanner on the top, which means it is actually running like a full SLAM, full odometry, and then localizing itself against uh, the space, right? So next time when you start the robot, like when you bring up the robot, it doesn't need to create this point cloud which is being on the bottom left, right? uh, so this is one robot in a lab environment, but think of robotics being deployed in the real factory floors, right? You can't have every robot to create its own version of the scan, which means you can't have so many versions of different point cloud created by so many robots, which doesn't, have are sharing similar coordinate system, similar ground truth, because it will become like a headache to manage so many point clouds at a time, right? So with multiset, what you could do is have a single source of truth for all your robots which are sharing the same physical space, which means when you go and deploy a robot in a physical environment, they don't need to create this point cloud on the first run, right? Because it's costly, it's hard to maintain. They can simply on the day first, because you already have mapped from a 3D scan or from a slam scan, you can use that map and put it inside a robot, and then the robot uses that map for navigation, localization, and so on. So what it unlocks for robotics and physical AI is the deployment becomes so smooth that you don't need to um, scan full factory every time a new robot comes. You can just have one source of truth, like one 3D scan, and with multiset you can share it across with robots, with humans, with devices that are sharing the same physical space. So that's the higher level unlock which it does.
I wanted to ask about those meta glasses back because you were showing that you can track them and even show the
Hmm.
position and rotation of those glasses. But how do you get the navigation? Because these glasses actually don't show anything in AR, right? So how do you get the instructions?
Yeah, so there are two ways. These glasses are getting really advanced. Some of these glasses now also have a 2D display on the right eye, or some of them have display in both the eyes. So you could show display as they are moving. But we did like a demo where which we are showing here is in a like this particular demo is in like a space where a normal meta ray ban generation 2 which doesn't have a display. So what the companion, and this is a demo which is out there, developers can recreate this using our open source GitHub samples out there. So this is what it is doing here. As the person is walking, it is capturing its camera data, comparing against with the database, and then on the top left you see the uh, the dots being moved, the sort of a blue dot being moving into the space. So it's basically, as you're moving into the space, you're seeing like a 2D navigation, what you're seeing in your Google Maps on your phone. But what it is using is your uh, Ray-Ban's camera to recognize where exactly you are in the space, and then showing you guidance in the phone, as well as it also gives you audio, which I'm not sure if you can hear them, but it gives you like audio, hey, move left, move right, as you're moving into the space. So it has a companion app as well as audio based navigation.
Can you walk us through steps like okay, we already explained how people can leverage, they already scanned the data that they can offer the navigation, for example, for the site or for the client. So what they should do next, how does it work with onboarding? Do they just create an account on your platform? Do they just upload the data sets? How long does it take to process the data set?
Yeah, to get started, yeah, simply create a free account on Multiset. We have varieties of SDKs. So whatever I showed today, we have SDKs and template sample apps. So if you're, let's say, familiar with if you are familiar with coding, which a lot of things it could be vibe coded, you can create an account, a free account. You can either download our app to scan an environment, or if you already have a 3D scan, you can upload that. Simply we allow all the scanner types in our free plan, which means you don't need to even go on a paid plan to unlock any new features. So, and then you can download our Unity SDK. If you're familiar with Unity app development, you can download our Unity SDK, which has a lot of these samples inbuilt, as well as you can go on our Multiset YouTube channel, which has step-by-step tutorial of doing this one-on-one, right? So to
Do I need to be familiar with the coding to try this or not?
very basic, as long as you if you're, let's say, starting with our SDKs, Unity SDK, it's all templatized, which means you don't really need to code anything. It's all configuration. But if you want even something low code, you can go to our partners websites like Zappar, Mattercraft, Spaces, or even 3ds, which have built like a custom UI on top of Multiset, where if you don't want to get into the code and just want to try all of this, you can create an account in Multiset, upload your scan, and then you can go on to, let's say, a Zappar, Metacraft, which will gives you a no-code tool to do this all without writing a single piece of code. But if you're slightly familiar, we have SDKs for every medium: Unity, Native, Meta Ray Bands, and whatnot.
Is there anything you would like to say to our audience towards the end?
If you have some free time, we have amazing free tier. If you have already a 3D scan, do give it a try. You can unlock so much more value, whether it's navigation, whether it's 6 degree of freedom of tracking, or if you are in robotics and going that direction, you can unlock that value. So it could start, you can start with the hobby project and understand what it can unlock for your clients or your customers, and then go deeper. Talk to us. We have amazing support channel on Discord, so which where is community, we keep posting what people are building, what other community members are building. So join our Discord, see what others are doing. Start with the free tier and then go and talk to us, and we can help you on unlocking a lot more.
Thank you for doing this, Nick. It was great. I'm definitely eager to try it and to have first discussions with my current or previous clients, because this is a really great opportunity to upsell them and to reuse and to resell the service that I already have done for them. So thank you for that.
Yeah, thank you, Michael, for
Perfect.
inviting us. It was great chatting.
Thank you, Nick.
Thank you,
Thank you,
everyone.
guys.
Have a
Have
great
a great
day.
day.